Okay class, let's say one more example on non-homogeneous second order differential equation where involve fx as a trigonometric function as fx. Okay, so we will try to solve this equation, and you need to always remember that every time we solve our non-homogeneous differential equation, we need to find the solution in terms of y equal to yc plus yp, where yc, when we consider our second order part as a homogeneous. Let's solve for yc first. So we rewrite this second order differential equation, d square y dt square plus with y equal to 0 to let it to be homogeneous. Turn it to be characteristic equation, therefore we will have lambda square plus 1 is equal to 0. Okay, so we have our a here is 1, our b is equal to 0, our c is equal to 1. So when we check our case, b square minus 4ac, we will have 0 square minus 4 times 1 times 1. So you will have negative 4, where negative 4 is less than 0. So when you have your lambda equal to, when you have your b square minus 4ac is less than 0, means this case falls in case number 3, where we have a complex root. So we need to solve this quadratic equation by using quadratic formula. So we solve it by using negative b plus minus square root of b square minus 4ac divided by 2a. So you will have negative 0 plus minus square root of negative 4 divided by 2 times 1. Okay, so we will have plus minus square root of 4i divided by 2. So you will have plus minus 2i divided by 2. So you will have plus minus i. Okay, so from this equation you will have your alpha equal to 0 and your beta is equal to 1. So to write your yc, we will have exponent alpha t. Okay, exponent alpha t, so you have exponent 0t times with a sine bt, so a sine beta t, so a sine 1 times t is t, plus b cos beta t, so b cos 1 times t is t. Okay, and exponent 0 is equal to 1, so you have your yc equal to a sine t plus b cos t. Okay, so from this solution, you will get your y1 and y2 as sine t and also cos t. We just list it because this involves the trigonometric function. Okay class, so now we want to find what is the yp that we want to use for this fx. Okay, so you need to list the family of derivative for both function cos and sine here. Okay, so when you write down the family of derivative for the first one, cos, integrate cos, you will have sine, differentiate cos, you will have negative sine, but we just ignore the negative one in front, so we just write sine t. Differentiate sine t, again we will have cos t, differentiate cos t, we again got the sine t, and we circulate in the same derivative, so we have this one as the family of derivative for the cos. And I believe everyone alert that the family of derivative for this function is also same as this one, because you differentiate sine, you will got cos, you differentiate cos, you will again got sine, when you differentiate sine you got cos, so this one is the family derivative of both of these fx. Okay, therefore our yp will be c sine t plus d cos t. Okay, but then before we proceed, we need to check whether this yp and yc is linearly dependent or linearly independent. So if you can see here, your yp is also have sine t and cos t, where it is this exactly the same with your yc, where your yc have a solution sine t and also cos t. Okay, therefore this is the linearly dependent. So when linearly dependent, what you need to do is you need to times everything here with t to the power of 1. Okay, so you have your yp in this term. So when you have your yp in this term, next you just need to find what is your yp prime. So how to find your yp prime? You need to do the product rule, where this one is v and this one is u. Okay, so let's use the product rule. So what you will get here is u times with dv. So you will have differentiate sign is cos, so c cos t plus minus t sin t, okay, plus with v, so v is sin t plus d cos t, du is 1. Okay, so let me write for you. This one is u, this one is dv, plus with this one is v, this one is du. So this one is the formula of product rule. So when you expand your equation, you will get is either you want to expand it or you want to leave it like that. So let's leave it like that first. Okay, next we want to find yp double prime. Okay, so to find yp double prime, you need to use the product rule, but the product rule again for this term. Okay, for this term you need to use product rule again. So let's use the product rule. You will get you will get your u as t, dv as c sin t minus d cos t, plus with v, your v is c cos t minus d sin t, du is 1. Okay, plus with differentiate all these terms. Okay, you will get c cos t minus d sin t. Okay, okay, so we already have our yp prime and yp square. So what we need to do is we need to substitute all these derivative in the equation here. Okay, so we have yp double prime. Let's write yp double prime, but to be easy, let's write it according to the trigonometric function. So you have your yp double prime. Let's put cos t outside. Okay, so what you will have for here, cos t is negative d c and also plus c. Okay, and don't forget to times negative d with t. Okay, so you have negative dt then you have c plus with c, you have 2c for cos t, so plus 2c, plus put sin t outside. So what you have for sin t is negative c, negative d, and also negative d. Okay, and don't forget to times negative c here with t, so you will have negative ct. Okay, minus d, you will have minus 2d. Okay, so this one is for yp double prime. Okay, and you need to plus with y, so your y is all here. So plus with, let's open the bracket, so you will have ct sin t and dt cos t equal to your fx here is 2 cos t plus 4 sin t. 2 cos t plus 4 sine t. Okay, now let's solve this equation or simplify first the left hand side. Okay, if you can see here, you have negative ct sine t plus with ct sine t. Okay, you have here negative ct sine t plus with ct sine t is finished. Okay, then you have negative dt cos t plus with dt cos t also finish. Okay, so you left only with here 2c cos t, and here you see negative d sine t equal to 2 cos t plus 4 sine t. So when you do a comparison from left hand side and right hand side, you will directly see that 2c here is equal to 2. Okay, therefore c is equal to 1. Okay, and you can see negative 2d is equal to 4. Therefore your d is equal to negative 2. Okay, so now you already have your c and d put back in your yp. Okay, so your yp is c sine t plus d cos t times with t. So you already know the value of c and d, so c is equal to 1. 1 times sine t is sine t, so just put sine t plus d times cos t. Your d is negative 2, so you have negative 2 cos t times t. So this one is your yp. Now you have your solution. Y is equal to yc plus yp. So here is your yc. Okay, a sine t plus b cos t plus with your yp here, so you have sine t minus 2 cos t times with t. Okay, so either you want to expand or you want to leave the equation the answer like this. This is the solution to your second order ordinary differential equation by using undetermined coefficient when it's involved the trigonometric function as its fx. Okay, thank you.